Between quadratic inequalities and quadratic equations is just that we've changed the equal sign to a less than or greater than sign. So we're not actually going to graph all of these. We're going to kind of minimize the part that we have to know. I told you guys this wasn't even like a full section in your book, but it's important that you're able to do this skill when you move on. And it's a little bit different than people normally think about it. There's one big mistake that people make, and we'll see what that is at the end. So the first thing I want to do is I want to graph this quadratic, okay? And instead of as an equation, I want to graph it as an inequality. But graph it first on your calculator as an equation. So just go ahead and graph y equals negative x squared minus 13x minus 36. So we're just starting with part B. I'm going to graph it by hand, but I just wanted you guys to see the values on the calculator. Okay, what do you guys see? Is the parabola concave up or concave down? Concave down. Is that surprising to us? It shouldn't be. Okay. Where are the solutions? Just glancing, where do they appear to be? -4 and -9. Now notice, I rewrote the inequality out over here, okay, and it actually factored. So does it make sense that you see the graph crossing at -4 and -9? Okay. So if we were graphing an equation and not an inequality, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And then let's see, for our vertex, I don't know, what's halfway between -4 and -9? Right here, right? So you guys find your vertex on the calculator. I'm going to find mine not using the graph by hand. We'll see if we get the same answer. So you guys should be able to calculate the maximum and figure it out on your calculator. Mm-hmm. Oh, because we're doing that one. All right, does anybody confirm that this is what they got? Did you get -6.5, positive 6.25? Okay, so how I did it. So I'm trying to use this to review at the same time as we're learning something new, right? So a little review of how to figure things out on the calculator. How I did it, if I knew that these two were my zeros, I knew that the axis of symmetry had to be exactly between them, which would have been at -6.5. And then if I plug that x value in, I could get this y value of 6.25. So a little bit of review of how different ways we can graph parabolas by hand, okay, with our calculator, and how to figure out key information. Eric? Yeah, because your solutions are when these things multiply to equal 0. So if I said 3 numbers multiplied together to equal 0, you'd be like, okay, one of them is 0. But then if I tell you one of the numbers is -1, this is unchanging. It has no x with it. It can't change. But these ones have x values you could plug in to make them equal to 0. Okay? Once I knew where the two solutions were, I found what was directly between them, because that's where the axis of symmetry would have to be. So that was -6.5. Then I would plug -6.5 into my equation to get the y value that goes with it. So that would give me the vertex. Okay? So if I was just graphing the equation and not the inequality, we would have this current graph. And we would say that there are two solutions, right? We already talked about this, -4 and -9. And those would be it, because they're the only places that it crosses the x-axis. And when we find those solutions, we're basically saying, like what Eric just talked about, The negative is kind of a -1. It can't change. But looking at these other two factors when they would equal 0. That's why there's only two solutions, because there's only two places where I could change the x value to get zeros and have 0 as an outcome, right? But that's all because, in this case, solutions mean when we are equal to 0. Okay? But look when we change this to an inequality. This problem says y is less than this boundary. So first of all, can we be equal to the boundary? No. Okay? Which means, because it doesn't say less than or equal to, it just says less than. So this line is no longer going to be solid. It's going to be dashed because it is a boundary, but it's not a boundary that a point can lay on because we are not equal to that boundary. Okay? The next thing we have to talk about is where we would shade. And we talked about this with absolute value in a warm-up, that just because it's not a straight line doesn't mean it doesn't divide your graph. It is dividing your graph. It's dividing your graph to the stuff inside the parabola and the stuff that's not inside the parabola, right? And the question is, where are the solutions? Where is y less than the boundary that this parabola has made? Is it the area outside of the parabola or kind of within the U? What do you guys think? So I hear some votes for outside. If we're not sure, what can we do algebraically to figure it out? Sure, we can plug in a point. So let's say we test this point out here, 0, 0, a point outside, and we see whether or not it works. So 0, -0 squared minus 13 times 0 minus 36. That simplifies to say 0 is less than -36. True or false? False. This point does not make the inequality true. So should it be considered a solution to that inequality? No. Okay? So if it's not a solution and it represents points along the outside of the parabola, where are our solutions going to be? Inside. Okay? Does that make sense? Now, I want to try and relate this a little bit because we're going to jump away from the graph and do it without a graph. And I want you guys to understand what's happening. So what I want to do is think about this in a little bit different context. When we're solving these, we always talked about solutions being the incorporation of putting 0 over here for y, right? Our solutions were when the graph was equal to 0, and that's why we picked out 2. Okay? Now if we're solving it and it's in an inequality, it's not when it's equal to 0. If 0 replaces y, this is going to say, when is 0 less than the points that are along here? Okay? If I want this to be a true statement, and I have 0 on this side, and I want 0 to be less than whatever shows up over here, what is this going to have to calculate as? If this is a negative, does that work? Is 0 less than a negative number? It has to be positive, right? These would have to be positives for this to be true. Do you guys agree with that? So whenever I plug in an x, and then the y value I got out was positive, it would make this statement true, that 0 is less than the positive number. Okay? So you plug in numbers for x, you do a calculation. If it turns out to be positive, this is going to be true. Okay? So let's look at our graph. Where are the x's that if you plugged that x value into this, you know this calculation would turn out to be positive? Well, we want this calculation to be positive, right? Because if we, okay, so the x values have to be negative, okay? But if we plug in like -1, look at what we get on the graph, something way down here, right? Is that a positive value after we plug in the negative x? No, so it's not just negatives. Where specifically are the x values that if you plug them in, you're getting positive values after your calculation is done? Huh? Right, this would be the part of the graph, right, where the values came out to be positive, right? I plug in this x, I get something up here. I plug in this x, I get something up here. I plug in this x, I get something up here. But once I get here and I plug in this next x, I get something down here, and it's not going to work anymore. Okay? So the solution to this, what are the x values that if you plug them into this equation, you get stuff bigger than 0, or in other words, 0 is less than what you plug in? They're only these x values. right? Because that's the place where the graph was above 0. Okay? And even though 0 is over here, we want our graph to be more than 0. So that means our solutions in this case, it's not that x is -4 and x is -9, because we're not looking for just those two things anymore. We're looking for all the x's that make it bigger than 0. And that's all these x's between 4 and 9. Now, am I allowed to include 4 and 9? -4 and -9. What happens when we plug in -4? We get 0. Is 0 greater than 0? No. So because they didn't include the equal to, am I going to include -4 and -9 as my solutions? No. So I'm going to say that x is kind of, as long as it's sandwiched between -9 and -4, that these would be my solutions. Now, we're going to actually do some solving problems in a minute, but I wanted you guys to understand how it relates to the graph, because the graph is going to be a key in solving the problems. So do you guys just understand that we were looking for the place where the graph was above 0? Because if we plugged 0 in right here, we wanted 0 to be smaller than what we were getting as our graph. Okay? No. So if you're just graphing it, you shade the whole thing. What I'm talking about here is what the solutions are, because that's the next step we're going to take. And so we're not going to graph the whole thing every time to get the solutions, because we really just have to look at the x-axis and where it's meeting the requirement and where it's not meeting the requirement. So we're going to pare down the picture a little bit, but the picture is still like vital to our understanding of what the answer is. I understand you could have got the numbers -4 and -9 totally without the picture, right? You could have factored and had that those were key values and zeros of the quadratic, but you wouldn't have known what was shaded or where the graph was above it without looking at the picture, right? And so the picture is going to become really, really important. So here's our goal in solving. We're now going to take things you're not required to graph, but we want to be able to solve them. And we're going to skip the calculator part, and we're just going to go to ones with non-calculator, because this is how you're going to be tested on it. Okay? All right. So part A, already been factored for you. They already did half the work. Okay. So what are the key values going to be in my equation? Raven? 4 and -7. Someone else tell me how he knows that. Sean? Yeah, those are the two solutions. So this parabola crosses the x-axis somewhere at +4 or -7, right? Now, is it concave up or concave down, this parabola? Up, if we look at it on this side, right? And then the 0 is on the other side, because it doesn't have any sort of negative lead coefficient. So what I'm going to do is I'm going to draw a little sketch, okay? Just to help us understand the idea. And by little sketch, I mean it's not going to be nearly as pretty as our graph was. All I know is that this is happening and this is happening, okay? And then I'm going to be a little more specific about my endpoints. Should they be closed or should they be open? Should this be a solid graph or a dashed graph? Dashed. So I'm just going to go oops. Okay. They should be open. Okay. Now, this means, think about if this was a graph and we were shading. The shading is either going to happen between -7 and 4, right? Or it's going to happen around the parabola, so it's going to happen like before -7 and after 4. So what we can do is we can pare this drawing down even more if you guys want to. And we can say, I'm really just concerned about the x-axis. And the key points on the x-axis, let me make it an open point, is this open point at -7 and this open point at +4. Okay? And remember what we're looking for. We're looking for x values that if we plug into this inequality, they make the inequality true. Where are the x's that when I plug them in, I'm going to get stuff that's less than 0? And you can do this two ways. You can use this picture, and you can do it numerically, or you can do this picture, and you can already see the answer. Matt? Okay, well, let's see. Okay? So first, look at the picture. Where does the parabola reach values that are less than 0? So here's the parabola. Okay, so these would all be points on the parabola that their y values, or once you plugged in the x, you would get something that turned out to be less than 0. That's why the parabola is hanging out underneath the x-axis, right? So that means which x values correspond to those? Is it the stuff outside of negative 7 and outside 4, or the stuff between negative 7 and 4? Okay. If this is what we're looking at, these are all the x values that correspond to them, right, that are right in between. So that's a visual way to do it. Second way to do it. Look at the number line. You can do it numerically. Try plugging in an x value that is less than negative 7. So pick a number less than negative 7. Negative 8. And you don't even have to really, really plug it in. You just have to look at negatives and positive. So if you're plugging in a number smaller than negative 7, will this be negative or positive? So I'm plugging in some x value smaller than negative 7. If you put in a number smaller than negative 7 and you subtract 4 from it, are you going to get a negative or a positive? If you plug in a number smaller than negative 7, like negative 10, negative 12, and you subtract 4 from it, it's going to still be negative, right? Okay. All right, if we plug in a number smaller than negative 7 and we add 7 to it, is it going to be negative or positive? Like negative 8 plus 7 is negative 1, negative 9 plus 7 is negative 2. Okay, negative. And negative times negative would make positive. Positive, okay? Notice, graphs up here, positive, right? So the picture tells me and the numbers tell me. Either way, you don't have to do them both, okay? All right, let's say I plug in a number between negative 7 and 4. Okay? So let's say that this time I try I'm trying a number between negative 7 and 4. Okay? You don't even have to know exactly what the number is, and you should still know whether it's negative or positive. If you're plugging in here a number between negative 7 and 4, and you're subtracting 4 from it, will it be negative or positive? It's either a negative number and you're subtracting 4 from it, or it's a number still smaller than 4 and you're subtracting 4 from it. Negative or positive? Negative. What if you take a number between negative 7 and 4 and you add 7 to it? Positive. And then when they multiply, they will make a negative value. Notice the graph is negative in that portion of the picture, right? Below the x-axis. All right? Let's try the next area. The next area I would look at are x values that are bigger than 4. If I plug in a number bigger than 4 and I subtract 4, am I going to get a positive or a negative result? And if I add 7 to a number bigger than 4, and a positive times a positive would be positive. Notice that the graph is above the x-axis, okay? The picture and the numbers tell me the same thing. Then the question is, pick a way that you like to do it. Can you tell which one actually has the answers? So look back at what you're supposed to be finding. Okay? Here's our original inequality. Do I want my calculations to be negative or positive? Negative. I want them to be less than 0 when it's true. So you can see this two ways. You can see where the graph is less than 0 and know that these are the x values that correspond to that. Or you could look at just the x-axis and see if I want things less than 0, that's when I got negative results, and that was only with numbers between this range. Okay? So whether you see it graphically or you see it on a number line, you see that the place where we're getting the answers that meet the requirement are between the number negative 7 and 4. Right? And are we including negative 7 and 4? No. So our solutions would say that x is between negative 7 and 4. Is this okay? Alex? It can be a dashed line. What I'm saying here is I'm not sketching it for perfection. I'm sketching it to see where it's less than 0 or where it's greater than 0. That's why it's a sketch, and it's just helping me with the work for the problem. It's not part of the answer. Okay? Any other questions about that? Jenny? Mm-hmm. Okay, so we're only looking for either the stuff that is less than 0 or the stuff that is more than 0. And that means like the y values of the parabola. So on the graph, these two solutions represent the point where the parabola hits 0. But our solutions are going to be when it's less than 0 or when it's more than 0. So either I want this portion of the graph when it's below and it's less than 0, or I want this portion of the graph where it's above and greater than 0. Once I decide which portion I want, my solutions aren't about what the picture looks like. They're about which x values make that happen. So I either have to focus then, where is that on here, or look at it on here. Okay? Claire?
So, like, what is it on the number line?
Uh-huh.
It's kind of just to, like, check your answer for the graph.
No, you can do one or the other. So, like, watch. In the next one, I'll just use the number line.
And you can, like, plug in any number as long as
between the values that you're looking at. Okay? So let's do the next one. First of all, we can't do it until we compare to 0, right? You don't have to shade. I'm not asking you to graph. What were the directions? Solve. If it asked you to graph, it wouldn't have a 0 there. It would have a y. And if it said, it would say y is greater than, and then you would end up shading it. You would end up shading in the same area where we found the solutions. Okay? All right, so look at part B. We can't start it how it is because what number do we want our equation to be compared to? 0, because we want the solutions to kind of divide up our possible x values. So I'm going to set it equal to 0 or move everything onto one side. And then I'm going to try and find the zeros, and the fastest way to do that would be factoring it, as long as it factors, right? I'll be perfectly honest with you. If I'm going to test you on it, it's probably going to factor. If not, I would allow you to use your calculator to find the places where it crosses the x-axis. Okay? All right. So p minus 5 times p plus 1 is less than or equal to 0. Okay. So we can sketch a graph, but we've already talked a lot about the graph, so I want to just use the number line, and then I'll go back and address how that would look on the graph. Okay? So on the number line, where are my key values that are kind of dividing my x-axis into the place where the parabola is above or below? Claire? Good. So there's one at -1. There's one at 5. Are they closed points or open points? Closed points, because this would be a solid line if we did graph it, right? So closed, closed. So either there's going to be these positive, negative ranges depending on, okay, how the numbers work out. So I'm going to first pick a number smaller than -1. Okay? A number smaller than -1 when you plug it in here. So if you take something smaller than -1 and you subtract 5, it will be negative. If you take something smaller than -1 and you add 1, it will be negative. And together that will make positive. So this will be positive. Now, I don't have to be plugging in the numbers right now. How many people already know where it's going to be positive and where it's going to be negative because they have a little picture of the parabola floating around in their head? Yeah, okay? If you know this is concave up the way that we've written it, you should expect that it's positive here because you kind of expect this, right? Which means positive, negative, positive, above the axis and below the axis. So then if I plug in a number between -1 and 5, it would be negative here, positive here, which is going to give me negative. And then if I plug in a number bigger than 5, I'm going to get a positive times a positive, which will turn out to be positive. Now I'm looking for numbers that are less than or equal to 0. Okay? So that would be when the values were negative, which is this range of numbers right here, which means my solution is that x is between 5 and -1. Now, if this had said greater than or equal to 0, does anybody know how our solution would look? Claire? Uh-huh.
If it's supposed to be less than or equal to 0,
Mm-hmm.
why is it?
It's not that these numbers should be less than or equal to 0. It's after you finish this whole calculation, you should get something less than or equal to 0. And when we plug a number in between -1 and 5 in there, we already found out we get negative answer when we plug in that number. So we would get a number less than or equal to 0. These are x values, or p values in this case. But what you're comparing to 0 is the outcome after you've plugged them in. Okay?
Couldn't you say for if it was greater than, wouldn't you say x is less than or equal to -1 and then
if it had been greater than or equal to 0 that this problem asked about, then we would have shaded in these other areas over here, right? And when you have two separate areas, you write it as an OR inequality. You would say x is less than or equal to -1 or x is greater than or equal to 5. Okay? Uh-huh. This is an AND inequality, and it usually means there's values that are less than 5 and at the same time greater than -1. So they kind of have that maximum minimum restriction on them. All right. I want you guys to do the try these part A. So I want you to do that one. The 8d plus d squared is greater than or equal to -16. Okay, so if you got everything on one side and you factored, you should have seen that it was a perfect square, which meant you didn't have two key values as zeros. You only had one. Is that okay with everybody? So I factored it. -4 would be my key value. Now, this can be quick considering that it's squared. If I plug in any numbers less than -4, plug them in and it gets squared, what do I get? Positive or negative? Positive. If you plug anything in here and then you square it, what's it going to be? Positive. So numbers bigger than -4, it's still going to end up positive. Or if you knew this was a concave up parabola, right, with only one solution, you would know that it looks like that, and you would know it was positive on both sides, right? So what are we looking for? Are we looking for the places where the outcome was positive or where the outcome was negative? Positive. It was positive over here. It was positive over here. And this got included also. So what's our solution going to be? All real numbers. Min Chao, did you have a question? You don't have to graph it, but you have to analyze something, and let me show you why. Oh, let me get on here. Hold on. I'm going to show you why you have to graph it and analyze it. All right. If you don't analyze it in some way, shape, or form, so if you don't see the picture of the quadratic in your head and know where it's positive and where it's negative, if you don't know what the x-axis looks like, here's what could happen. See, this person factored it. They knew the values were at 3 or 2, but then they say things like x is greater than 2 and x is greater than -3, which doesn't make sense. There has to be some sort of analysis. The reason I say draw the picture is because not everyone in this room is at the same place. If I say, oh, yeah, you don't need to draw the picture, like as long as you know, then it's good. This is what people end up doing, okay? And this is what they feel like. See? This is what you'll feel like if you sketch the graph or the axis, or you at least know where it's going on. Okay, some people see this in their head, and I understand that. But what you don't get if it's automatically there for you and you got it that fast is that the people around you aren't necessarily seeing that in their head. And if they don't see it on the paper, they're going to write solutions like this when they should be writing solutions like this. So the question is, where do you know when it's greater, when it's less, which one's which? You saw a place where it was all real numbers. It's possible that it has no solution. It's possible that one number is the solution, okay? Or it's possible that everything except for one number is the solution, okay? Because like when you see those perfect squares, they hit right on the axis, right? Lots of things can happen, and whether or not it's included. So there has to be some sort of analysis that takes place. There's no quick rule like there is for absolute value. Like if it's less than, it's and if it's greater, it's or. You can't just memorize that because the parabola could be flipped different ways, and then that would change completely depending on which way the parabola was flipped. Now you can memorize a lot more rules. Like if it's concave up and it's like this, it's and. But if it's concave up and it's like this, and it's, or if it's concave down and it's like this. In case the situation when it sits right on the axis, then it might be all real numbers. There would be lots of different rules for you to memorize. So my advice is, feel like this, okay? Sketch the picture. He looks like he feels so awesome. Yes.
So when there's only like one solution, that it's always all real numbers?
No. Okay. So he said, if there's one solution, is it always all real numbers? No. Let's say we looked at the one that we were just looking at, and we just change it slightly. So we had d plus 4 squared, and it was asking when it was greater than or equal to 0, and that was all real numbers, right? Let's say we change this so that it still ended up being d plus 4 squared, And let's say we said when it's less than or equal to 0. Okay. This part's not going to be changing. Our critical value is still at -4, right? Still could be equal to 0, so that's filled in, but it's still getting positive on both sides of it. Okay? But now we're looking, when is the outcome less than or equal to 0? It's never less than 0, but it is equal to 0 in one spot, right at 4. This one would have just a single number solution. If I took away the equal to part, and that was open, then it would have no solution. So do you see how there are different cases depending on which way you're facing, what type of inequality it is? Okay? So definitely analyze.